Hey everybody, here's problem 7 on the chapter 14 homework. It's a lot like the last problem, problem 4 on the guided problem, very similar in its structure. So consider the set of ordered pairs below, assuming the regression equation is this. Construct a 95% confidence interval for x equals 7. So I'm going to open this in Excel. I'll enable editing, which for some reason will move it from where I really want it. Oh, stop. All right, so there's my data set. And so if I don't have the formula memorized, which most of us don't, I can go to view an example. It gives me the formula right here. I like to take the snipping tool and then just snip out a picture of that formula, copy it, paste it over here in Excel so I have it right here. Just makes my life way easier. That's not required, of course, but anyway, so now I have my data, I have my formula, and so what I do is I just start to figure out everything I'm going to need for this formula. So I'm going to need y hat, which is the predicted value of y for a given value of x. I'm going to need the critical t, or the t-score of alpha divided by 2. I'm going to need the standard error. I'm going to need n. I'm going to need x and x bar. I'm going to need x, the sum of x squared. And I'm going to need the sum of x. And then n again, which I already have. So that's all the data I'm going to need to work out this formula. And so the first thing I have to do is figure out, well, what do I know to begin with? Not much. I know n is the number of ordered pairs. So my n is 5 for this problem. X is given to me as 7, and that's all that's given to me. So now I have to kind of go through and calculate each of these. So y hat is just the value, this estimated value of y, or expected value of y is probably the better term, for a given value of x using this formula. So my y hat here is going to be 4.081 plus 0.118 times x. So again, I'm just using this formula that's given to me over here to solve for y hat. My critical t, I can find by doing t.inv.2t. It's a two-tailed test. My probability is I'm going to use my alpha. So if my confidence level is 95%, 1 minus that will be my alpha, so 0.05. And then degrees of freedom is n minus 2. Whenever we're doing these where we have two variables instead of degree of freedom being n minus 1, like it was in previous chapters, it's n minus 2. There's my critical t. My standard error, I can use the formula from the book, or I can go to data in Excel, data analysis, choose regression, hit OK, and then use my my y range is going to be all of these values for y. And if I highlight y up here too, then I have to click labels to let Excel know that my top one's a label. And then x is going to be my x range here. And then output is just where I want it to output to. And I'm going to put it at D. Whoops. I messed up. That's my y range. I have to click out here and then say I want it to output at D9. I hit OK. And it's going to give me a lot of data there. But I need my standard error, which is listed right here as standard error. So I'll say this equals the standard error. My x bar is just the average of all of my x values. To find my sum of x squared, I'm just going to create a third column called x squared, and that will equal the value of x squared. And I'll just fill that down. And then this will be the sum of all of those x squared values. And the sum of x will just be the sum of all of the x values. All right, so I've got all of the stuff I need to work out this formula, but this formula is super easy to make a mistake on because there's so many parts in it. So I'm going to walk through it, but then I'll also walk through a strategy, I guess, for if you feel like you're just making mistakes with it. So the margin of error, if we look at this formula, the margin of error is everything after the y hat. So what we're saying is if we have an x of 7, we expect a y, our expected value of y is 4.97. But to make a confidence interval where we're 95% confident that y will be 4.97 if x is 7, what we're actually going to do is make a range, an upper confidence limit and a lower confidence limit, to help us be 95% confident that if x is 7, y will be some number in that range. Okay, so the margin of error is the critical t times the standard error times this whole part that's in the square root radical here. Okay, so we can set it up by doing the critical t times standard error times the square root of, and then I'm going to do 1 divided by n plus, and then I'm going to do that first parenthesis is for this whole thing, right? So the second parenthesis is going to be just for this part. So I'm actually going to do a third parenthesis and do x minus x bar, close that parenthesis, and then square it and close that one. So there's my whole numerator. This part right here, x minus x bar squared. Then I'm going to divide that by, so this first one is to represent the full numerator down here. And I can just do the sum of x squared. I could probably get away with not even putting that in a parenthesis if I wanted to, but I'm going to anyway, minus, and then again, so I'm going to have a numerator and a denominator to deal with, and I'm going to square it. I'm going to do 3, okay? So I have the sum of x, and I'm going to square it. So there's the numerator of that little part divided by n. I'll close that. That closes the denominator. I close it again. That closes this whole part. I close it again. Actually, now that closes the whole thing. Close it one more time. That closes the whole part that's within the square root. And I think I have one more, right. So you have to match all those up. It's super easy to make a mistake. So there's my margin of error. So that is this whole part after the plus or minus. So now I can just say that my upper confidence limit is my y hat plus my margin of error, and my lower confidence limit is my y hat minus my margin of error. It wants 3 decimal places. So we'll just go down to 3. 11.336. Lower confidence limit is negative 1.522. There we go. So some people get kind of freaked out by the size of this thing, or it's super easy to make a mistake. I mean, look at all that, it's crazy. So some people would prefer to break this down into a couple different pieces. Okay, so like they'll do 1 over n, whoops, and then they'll just do this equals 1 divided by n. And then they'll do this numerator here, call it the numerator, and that they'll just say this equals x minus x bar squared. And then they'll do the denominator and say this equals the sum of x squared minus sum of x squared divided by n. Whoops, I just made a mistake. Hopefully I didn't mess it all up. That just gave me an extra parenthesis to close it. So then after they've done all that, they'll say, I want this whole fraction right here, which equals the numerator divided by the denominator. And then they'll say the whole part inside the radical is the 1 plus n plus the fraction. And then the whole radical is the square root of the part that's inside the radical. Then they'll find the margin of error by saying this equals critical T times standard error times the radical, the part that was inside, the square root of the part that was inside the radical. And so it comes out, you can see, with the same exact thing, but it's harder to make a mistake because you're breaking down this whole big part into different chunks. So some people like to do it that way. It's up to you how you want to do it. Okay. So I'm going to move on to the next question. And so this one's really similar, except it has a number set with 6. So I'm just going to grab this. I'm just going to pull it down a notch here. And then I'm just going to replace these numbers, because now that we have a calculator in place, why redo all of that making of those formulas? So my x values are 5, 1, 4, 4, 4, and 2. And my y values are 6, 3, 5, 4, 3, and 2. And so, again, I'm given this equation. So I'll just start with, I'm just going to go down it, okay, and fix things. So my y hat equals 1.383. That's this formula right here, plus 0.735 times x. There's my y hat. My critical T is going to change because it's 90% confidence interval. So instead of 0.05, it's going to be 0.1. And then it's still going to be n minus 2. My standard error to fix that, I'm going to have to do a new regression analysis with this new data. So I'm going to go to data analysis, regression, okay. And I'm going to fix Y to include all of those now. And X to include all of those. Still has labels checked, still output range to D9. I need to leave my output range the same because some of these are dependent on it, right? So I have all of that. So there's my new standard error. It's already there because it was connected. N is going to be the number of ordered pairs. This one happens to be 6. X for this one is 5. My average here is the average of A2 to A6, but I need to change it to A2 to, or I'm sorry, X, yeah, A2 to A7. Make sure that happened, it didn't. There we go. It's doing some weird stuff. Might just be easier. Sum of X squared, might just be easier to change this to a 7. So it's this whole range. And then the sum of X, again, change that to a 7. My margin of error is calculated for me. This is already calculated, this is already calculated because it all pulls off of this info. So that should be correct. Upper is 6.542 and 3.574. Finally, on number 9, it's again a similar problem. A little different in that it doesn't give us the formula here for y hat. So we just do the data. We find out this one has 7 ordered pairs. So again, instead of redoing that whole formula, I'm just going to grab this and pull it down. I'm going to put in my data. X is 24, 37, 26, 32, 43, 30, and 42. Y, 143, 178, 57, 195, 155, 144, and 205. Whoops, 205. All right, and again, so I have all my data in there now. I just have to come down and adjust my formulas because I now have another, I have 7 ordered pairs instead of 6. So because y hat's not given to me, I can use this information down here, but I'm going to have to redo, again, my regression analysis for this new data. So I'm just going to go to data analysis, regression. I'm going to replace this now with all the way through B8, B1 to B8. This will be A1 to A8. Still have labels, still output to D9. There we go. So now for y hat, I'm going to use these numbers here. Down here where it says intercept is going to be my y-intercept and my x. So I'm going to say this equals my y-intercept plus my x value times x. So that's how I'll figure out my y hat when it's not given to me. My critical t, I'm going to look at it, it's a 95% interval, so I'm going to change this to 0.05. And then it's still going to be the whole n minus 2, so that's good. My standard error is now 23.03, so that already carried over. My n is the number of ordered pairs, 1, 2, 3, 4, 5, 6, 7. My x is saying find the cholesterol level for a 30-year-old man. So I'm going to say 30 for x. So based on this data, this is telling us we think our approximate cholesterol level for a 30-year-old man will be about 162. Okay. X bar is the average of all the X values. Again, because we added another X value, we're gonna have to update this to cover all the way down to A8. Same with the sum of X squared all the way down to C8. And the same with sum of X all the way down to A8. And now it should all be right because our calculator is good. And we know it's good because we've already gone through 2 problems with it. So my upper confidence limit is 187.09. Oh no, it says 1 decimal. So 187.1. And my lower confidence limit is 137.1. So I'm 95% confident that from this data set, a 30-year-old is going to be between 137.1 and 187.1. And as long as we didn't make any errors transferring this information over, that should be right. All right, so there we go. So this is exact, these are all like problem number 4 on the guided problem. And then problem number 3 on the guided problem is different because instead of making a confidence interval, we're doing a prediction interval. And so it's going to have, the only difference will be in this formula right here, it'll have 1 plus 1 over n plus all of that. And that's it. And everything else is the same. So I hope this helps, and I hope maybe seeing it done this alternate way is valuable as well. So that if you wanted to try to break it down into pieces, you know, that might help not make to make fewer mistakes. Anyway, good luck, and if you need to, let me know, and we'll meet together and go over it.